Hey everyone, welcome to part one of our four-part explainer series. Today, we're diving straight into the absolute blueprint for architecting Azure API and integration patterns. If you've been working in cloud environments for a while, you already know that making your apps talk to each other securely and efficiently is pretty much the backbone of any modern system. So, in this explainer, we're going to break down the exact strategies you need to build highly scalable, completely resilient architectures on Azure. Here is our roadmap for today. We'll start with the Azure integration scenario, check out API management as the front door, look at choosing your compute backend, weigh sync versus async processing, talk about decoupling with Azure messaging, and finally, wrap up with 3 foundational architecture patterns. All right, let's get into it. So, Section 1, the Azure integration scenario. To really wrap our heads around these cloud patterns, we need to ground this in the real world rather than just looking at abstract ideas. Think about a typical e-commerce setup. Step 1, you've got external clients making an API call, like, placing an order. Step 2, that request hits a synchronous API gateway expecting an immediate, secure acknowledgement. But step 3, well, that's where the magic really happens. Instead of making the users sit there staring at a loading screen while we check inventory, process their credit card, and update shipping, we transition into asynchronous internal processing. Going from that external trigger to background execution, that's literally the bedrock of modern cloud architecture. Moving right along to Section 2, API management, the front door. There's a super common misconception out there that API management is where your core business logic lives. Actually, scratch that. It completely doesn't. It's really just your vital synchronized front door. It receives that external request securely and then hands it off. We're talking rate limiting, IP filtering, JWT token validation, the whole shebang. It essentially acts as a traffic cop, making absolutely sure that only legitimate requests ever make it into your internal Azure ecosystem. So you're effectively shielding your back-end systems from the wild west of the public internet. Okay, Section 3, choosing your compute backend. Once we're safely through that front door, the request needs an engine, right? It needs something to actually do the heavy lifting. And Azure gives us a few distinct compute backends to choose from here, and your choice really dictates how your system will scale. If you're migrating a legacy app or you just need traditional web hosting, Azure App Service is your reliable go-to workhorse. But if your team is already deep into Kubernetes and you need that intricate containerized microservices orchestration, then Azure Kubernetes Service, or AKS, is definitely the powerhouse you want. And finally, if you just want to write targeted pieces of code that spin up instantly based on triggers without even thinking about the underlying infrastructure, Azure Functions gives you that awesome serverless event-driven agility. Next up, Section 4, sync versus async processing. This right here is probably the most crucial architectural shift we're talking about in this explainer. Think about it. If we force the client to wait synchronously while our backend computes, like while App Service or AKS reaches out to a database, validates a credit card, generates an invoice, we create a massive, massive bottleneck. The user screen is just spinning, right? They're frantically refreshing the page, which honestly only makes the problem worse for our servers. So we have to pivot. We move from synchronous waiting to an asynchronous fire and forget model. We instantly shoot an HTTP 202 accepted back to the client right at the front door, while all that heavy, complex internal event processing happens completely seamlessly in the background. It's a total game changer for speed. Because decoupling is not just some trendy architectural buzzword. It is literally the ultimate survival technique for scalable, resilient applications. By physically separating that synchronous front door from our background compute engines, we protect the entire system from cascading failures. Think about it. If your backend billing service goes down for 10 minutes, your external clients can still place their e-commerce orders. The front door stays open, the requests are captured, and absolutely nothing is lost. That is the true power of decoupling. Which leads us perfectly into Section 5, decoupling with Azure messaging. So how exactly do we bridge the gap between the front door and the background engines without tying them together? Ask yourself, how do we prevent our compute systems from bottlenecking and crashing the second external traffic suddenly spikes? Picture a Black Friday sale. This is the exact nightmare we face in tightly coupled monolithic designs. The front end gets hit with a million requests, the back end tries to process all million requests at the exact same time, runs out of memory, and boom, the whole house of cards collapses. Developers are stressing out on a holiday weekend. No one wants that. The answer lies entirely in Azure's specialized messaging tools. The first of these tools is Azure Service Bus. You can think of Service Bus as your heavy-duty shock absorber. It's a highly reliable enterprise message broker that essentially acts as a secure courier. When API management takes in, say, 1,000 Black Friday orders a second, it doesn't force your Azure functions or containers to process them all at once. No way. It hands those orders over to the service bus. The service bus safely queues those messages up, buffering that massive traffic spike, so your compute backends can just pull them down and process them at their own safe, manageable pace. It completely smooths out those crazy peaks in traffic. And right alongside that, we've got Azure Event Grid. While Service Bus handles the heavy, high-value queuing of specific messages, like an actual order payload, Event Grid is our rapid-fire broadcaster. It's a highly scalable, serverless event routing service. Let's say a payment is successfully processed. Event Grid acts as the broadcaster, basically shouting out to the inventory and shipping services that a state has changed. It doesn't hold the heavy data itself. It just yells, "Hey, this thing happened," so that multiple decoupled microservices can instantly react and do their jobs simultaneously.
All right, let's bring it all together in Section 6, 3 foundational architecture patterns.
We're going to synthesize this whole request journey into the absolute essentials, the patterns every Azure architect absolutely must grasp to be successful. Pattern number 1 is the API gateway. You really must use Azure API management to centralize and secure all of your synchronous external client calls. This pattern guarantees you never ever expose your backend compute directly to the public internet. You're always using that dedicated traffic cop to maintain control, enforce security policies, and manage client expectations before a request goes any deeper into your infrastructure. Next up is pattern 2, asynchronous queuing. This is where you leverage the Azure Service Bus to buffer traffic and physically sever or completely decouple your front-end API gateway from your back-end compute engines. By implementing asynchronous queuing, you guarantee that even if your back-end Azure functions or app services go offline temporarily, for maintenance or due to some error, you never lose a single client's request. They just wait safely in the queue until the back-end comes back to life. And our third and final foundational pattern is publish-subscribe routing. By using Azure Event Grid, you can broadcast internal system state changes instantly. This is the pattern that unlocks true horizontal scalability. It lets various internal systems, maybe it's your analytics engine, your notification service, and your database updater, all react to a single e-commerce event completely independently of one another. No more tangled webs of fragile point-to-point connections. So, I want to leave you with a final, really critical question. Where in your current architecture are you tightly coupled, and how can Azure messaging set it free? Seriously, take a hard, honest look at your blueprints today. Ask yourself if a single compute failure could bring down your entire front-end experience. Because the API management, compute, and messaging patterns we just covered, that is exactly how you build unshakable resilience in the cloud. Think on that for a bit, and I really look forward to seeing you in part 2 of this series as we continue to build out our Azure mastery.